Let's take a look at a new power supply. Now the reason why I'm excited about this power supply here is because it is the 60 volt 5 amp model, and this M is actually, I'm sorry, the D is actually important too. The D means it counts out to 4 digits. They have a 3-digit model that's a little bit cheaper. But now if we take a look at my older power supplies, here I have my unit Ts, which are the 0 to 30 volt, which if you're shopping for a lab style bench power supply, you're going to find that 90% of the power supplies in the market are 0 to 30 volts, which is great for industrial 24 volt stuff. It's great for automotive voltages, and it's great for your 5 volt logic, normal low voltage shenanigans. It's good for that, and these are also 5 amps each. But if you're ever going to work with either LED lit TVs or LED lighting of any kind, there's usually going to be many LEDs in series, and it's going to require high voltages. And that's why I have this model here. This goes up to 120 volts DC, but this power supply can only do 1 amp. So it's not really good for general purpose stuff. And these are good for general purpose stuff, but not good for LEDs. And then we have this, which kind of fits right in the middle. So this is 0 to 60 volts at 5 amps. So it's high enough to do LED lighting type projects, but still enough current for fitting all sorts of other general purpose power supply needs. You could even charge your car battery with these 2 at 5 amps fairly quickly. As of the filming of this video, both models are in stock. You have the 3-digit model is 6690, and the 4-digit model that I have here is 7090, which is actually cheaper than what I paid for these other power supplies here. I think I paid around 130 or 140 for the 120 volt model, and these unit Ts are usually right around the $100 mark. Prices fluctuate quite a bit. The stock and price fluctuates on Banggood quite a bit too, so I'll put a link down in the description. You can click on it and see if it is still at $70 and if it is in stock. This was actually out of stock for me the first time I tried to get it, and I think one of the reasons why it's a little more popular is because Banggood has a ton of power supplies, but only a few of them are good for 110 volts. A lot of them are 220 only. This one here has a switch. I got it set to 115 now. Of course, this power cord isn't going to do me any good here in the States, but at least it uses your standard old school PC power cord, so that's no problem. Now, part of the reasons why this is cheaper, smaller, and lighter is because it's a switching power supply, which these are not switching power supplies. These are called linear power supplies. So they have a giant transformer inside that runs at the 60 volt, or I'm sorry, the 60 hertz line at the 120 volt line voltage. But anyways, where this will operate at probably a couple thousand hertz, which is more efficient for running current through a transformer. But now you're dealing with high frequencies, which can also send those noises. It can actually transmit them through either both RF or throughout the actual outputs too. So we're going to see how noisy this is. For my application, I don't do like ham radio or anything, so I don't think any noises are going to be a problem for me. We'll see if it's grounded, we'll see if it's shielded, and let's just take it apart before we turn it on. Wow. Okay, so this big plate right here is the heatsink for the switching MOSFETs. I see 3 of them down there. I'm assuming those are MOSFETs. I suppose one of those, a couple of those could be a diode. Anyways, I'll look closer later. I see 3 different brands of caps in there. No, we have some black Ching. I don't even know how to pronounce that. Chong. I don't know. You know, your typical cheap Chinese electrolytics there. This is also just some cheap Chinese electrolytics. I can't quite see the label on the black ones there. Let's see if I can get some more light on this thing. There's our fan. All right, let's see if the ground, let's see if it's grounded. Yes, so I do see our yellow and green wire is tied to the aluminum, and the aluminum is screwed to the case, so there is an effort in grounding so the case can't become hot, and it should also help shield any noisy RF sort of frequencies that want to blast out of this thing. It doesn't look half bad. All right, so it looks like the AC comes in through here, it runs up to the switch, and then to a plug on the board. Again, this must be for the fan. Yes, it is. And another plug for the 120 volts, 220 volt switch. I see some current shunts for measuring the current, a couple of nice chokes, and of course here's the main transformer that is going to be operating at a high frequency to supply up to 5 amps. And there's the front of the board if you want to see the display board. Let's take a look at these banana plugs. Let's see if it has a hole through it. I really like it when they have the holes. Sometimes they do, sometimes they don't. And no, there's not a hole all the way through for just jabbing a wire into, but banana plugs, this fits nice. I don't got any complaints about that. I noticed it came with your little starter cable here, alligator clips, and that should, yeah, that would fit out there nicely. Yeah, this wire is probably just heavy enough for 5 amps. All right, let's turn this thing on, huh? All right, I'm going to apply some power to this thing. I'm still set to the 115 volt, and did you see we had a quarter fan spin? Let's try that again. What the hell, it shut off and it's still on. That's one hell of a capacitor in there. Geez, that took a long time to shut off. Yeah, so I'm assuming the fan is maybe some kind of, it's maybe thermal controlled or current controlled. I'll have to see what it takes to get that fan to kick on. So we got here, okay, so yeah, we got our fine at the bottom voltage on this side. It's slow at responding too. There must be another capacitor, a large capacitor across the outputs. Maybe it looks like the jack connectors go straight up there, so that capacitor must be directly across, which concerns me because that would mean the current is not going to react fast enough. So after playing with this thing for a few minutes, I noticed that if you start it with everything on minimum, and then if you increase the voltage, so right now the volt's maxed, it actually isn't allowing enough current to charge that capacitor that's across the terminals to reach 60 volts. So I actually have to allow it some current. Okay, so after looking at this for a few minutes, I think it's starting to make sense on why it's acting a bit delayed on the output. So the AC comes in through here, passes through some filtering, full bridge rate rectifier. We got our main high voltage caps that are going to be storing the rectified line voltage. And then we have our two, pull up, pull down style, push pull, however you want to call it, MOSFETs. That is then driving the transformer. And then there's just a diode, more filtering, and then here's our output. So this is where it's sensing current, but there's no other semiconductors on the back side or hidden anywhere else. There's none on the bottom side of the board. So that means all of the control is done on the primary of the transformer. There's no other switching semiconductors that can control what's going on the secondary. So there's going to be a delay from, it's going to take time to go through the filters and capacitors before it makes its way to the actual outputs. And maybe that's what's throwing me off. See, I'm not used to that. My old linear power supplies are more in control of you're actually seeing at the binding posts. I do see a thermal sensing component shoved into the heatsink compound. So I'm assuming that is how it senses the temperature to know when to turn the fan on. So I'm going to give this thing another hard run. Let's see if we can make this thing hot. Another thing I notice is that it doesn't start showing current draw until you get about a quarter of the way up. There's a bit of a dead spot on the minimum, and that's even with the little trimmer, the fine trimmer turned up. So you get about a quarter of the way, there's a dot right there, you get about a quarter of the way up, and then right there it starts pulling. See if I can get it controlled. Nice low amount. See, if I was maybe checking some LEDs, I don't want control under 100 milliamps. I guess it does allow for that. I'm going to see if I can maybe pin it down to like 10 to 20 milliamps. Yeah, it is possible. Let's crank this up, make this thing pass some current. So there is our rated 5 amps. And of course the voltage is going to read low because, well, it's got just a wire just shorting it out, so you're not going to get any voltage across that. A little bit of a voltage drop across my wire. But here we're sitting at our 5 amps. So far the fan is not kicked on, but our heatsink is still cooler than room temperature pretty much. It's still cold to the touch. I'm just going to let this sit here for a little while at 5 amps. What? Oh, I think I know why it's... I think I know what's going on here. Is the plug in the back is a little loosey-goosey. And I noticed that is the same deal with my unit T's. So if you're moving this thing around, if you jiggle the plug, it might cut in and out. All right, there's the fan. I took about 12 minutes. So the fan is thermally controlled, automatic thermally controlled, so that's cool. It's not very loud either. See if I can get the microphone up to that. Yeah, pretty quiet. That's impressive. All right, to stick with the theme of shorting this thing out, let's check the current. We're going to compare the fancy 4-digit current with my my unit T meter. We should be in 10 amp mode. Yep, so let's go ahead and start turning the current up in there. Yep, like I said before, you have to get about a quarter of the way up before it starts to, oh, I turned my voltage down. That's why it's not going. There we go. All right, so the numbers are pretty accurate. Again, we're comparing a Chinese meter to a Chinese power supply, but yeah, it looks pretty good. But I am not an engineer. I'm just a technician. I don't need perfection. All right, and now let's compare the voltage readings with my unit T. Let's get this switched over to volts. And all right, so here's our constant voltage and constant current indicators. And it's just strange that it needs to turn. You need current to charge those caps on the output. It's just I'm not used to that. Anyways, let's move on. Let's check a few voltages. I'm gonna see if I can get this right on 12. See how easy it is to set this on 12. I'm gonna use the fine point. All right, so there's our beginning of the automotive voltages that you might want this for. See if I can get that right on the nuts. There, 12. It's a few tenths off compared to my meter, but you know, whatever. Let's try 24. There's our 24. Well, that's right on. We'll go to the very, very max. A few tenths off again there, but whatever. All right. Looks all right so far. So far, it's doing what it's advertised to do. Next, I want to see if there's any weird power-up anomalies where it maybe shoots the voltage up when you first turn it on. So I'm just going to start with it all the way down to minimum. Let this thing kind of get towards 0. All right, so I've got it dialed into 5 volts. And I'm going to use the max hold again on the meter. And we're going to pretend we have some sensitive piece of equipment on the outputs. We're going to power it off, let this thing shut off, let them caps discharge. Any minute now. Okay, so now it's off. We're just going to flip it on and make sure this doesn't spike up. Well, it did. I guess it did spike up a half a volt. I mean, I don't think that's going to blow up any 5-volt devices. I guess that's acceptable. Let's just do it again. I'm going to reset my meter. Put it back in the max hold. Let's power down all the way. Click it on. Let's see what happens. Yeah, I guess it did jump up to 5.5 again. It's not perfect. That's not the end of the world. Let's do the same thing on 12 volts. All right, so there's 12. Reset my meter, put it back on max hold, power it off. And now we're just going to pretend we left something plugged in on the outputs, some automotive, something you're working on, and we're going to power this on while it's still set to 12, and we're going to see if it jumps above 12. And no, 12. My meter is auto ranging, but it is 12. It didn't jump. Okay, that's acceptable. The next test I'm going to give it is I'm going to drive an LED directly with it, and I'm pretty much guaranteeing it's going to fail this test just because it's a switching power supply. Well, in fairness, my other power supplies don't really pass this test very well either, because those also have capacitors across the output. But anyways, my point, what I'm getting at here is I'm going to try to dial in maybe 20 milliamps. That should be pretty acceptable for this LED. Let's get the voltage up to around 2-ish. All right, so there the LED's lit up. I should be able to find the point where we're going to switch over. The constant current light is going to kick on. There. What I'm trying to do is get this right around that 20 milliamp mark. So that's what this LED needs to run, is about 20 milliamps at a couple of volts. So now that it's set, the current set's 20 milliamps, I should be able to crank this up. What the hell? Why did it just jump up to 100 some? It's kind of struggling with this small. All right, there, I got it. Okay, so now it's locked in. 25 milliamps, 2.2 volts. And now theoretically, I should be able to crank the voltage all the way up to 60. All right, I'm going to even crank up the fine one too. So now it's completely max in voltage. The current is set to the 25 milliamps. There's a little constant current indicator. So this is going to blow the piss out of the LED, but I'm going to try it anyways. I'm going to disconnect the lead. We're going to jump up to 60 volts. If this was a really good power supply, I should be able to connect this up and it should be able to adjust its voltage down fast enough in time to not blow the piss out of the LED. But I'm going to put, well, 61 volts on this LED, and we'll see if it reacts fast enough. It's not going to. Yeah, it just blew out the LED. That's all thanks to the rows of capacitors across. So my point was, it wasn't able to bring that current down fast enough. Those caps held too much of a charge. All that means is that you just have to keep that in mind when you're testing LEDs. So here's a more practical application for a power supply like this. Here I have an LED strip out of a TV. Now if I wanted to test this, this has 10 LEDs in it, and to get to 3.3 volts, we would need 33 volts. So your standard lab grade bench power supply that only goes up to 30 volts might not go high enough to really fully light this up and to test it, but this will. So I've got this set to 33 volts, got the current locked in at 100 milliamps. I could increase the current, but I set it to 100 just in case, say there was a shorted LED on here. It won't allow the current to go to an excessive amount. But anyways, this strip is nice and has some test points on it. And there. Well, I suppose it'd help if I'd get it in shot. Let's switch over to the wide camera. There we go. So we have all of the strips, all the LEDs lit up. So that just shows off what this thing can do that maybe a normal one couldn't do. So if you're willing to settle for the quirkiness of a switching power supply, you might as well buy a 60 volt model. Now, if you're a power supply snob, maybe don't settle for a switching power supply, because this definitely is a little bit more finicky on the current control, and there's just that lag in control from when changes are happening at the transformer until when you actually see them at the output. So that's a little annoying, but you know, we're talking about a $70 power supply, so really how upset can you get? Because this is cheaper than all my other ones. And it does have a fuse on the back plug here. And I did notice even after this ran at 5 amps for the 12 to 13 minutes or whatever it was to get the fan kick on, the heat stink still felt pretty cool to the touch. So, you know, at least it's pretty efficient at what it does, I would think. So, yeah, that wraps up this one. Thanks for watching.